Hey guys, welcome to question MM219 of the Maths Methods Fortify study guide. Now we're going to start with part AI, obviously it's the first part. So let's just dive straight in. Actually let's just run through the question. So a particular model of Chinese kite, model A, is in the shape of a square-based pyramid, and the shape of each face of each triangular side of the pyramid is given by triangle ABC below. So this triangle here shows us the face of each triangle section of the pyramid. Now, part A tells us the length of each edge from point B is 25 centimeters, which is this bit here, and 2 theta is between pi on 2 and pi, okay? M is the midpoint of AC, so this is the midpoint here, and we need to show that the surface area of model A, the kite, is given by SA equals 2500 sine theta cos theta plus sine squared theta. So that's our goal right here, to get this surface area. So, first things first is to figure out how to actually find the surface area of a pyramid, okay? So we know that the surface area is going to be equal to the 4 triangle sides, so 4 times the triangle area, plus the area of the base. So the square base, right? So this is a square base pyramid like this, and we're going to need to find the area of the base. So plus the base, which is a square. So let's start by finding the area of each triangle, all right? So maybe let's just jump up here. So the area of a triangle is equal to half times base times height, as you guys know. Now, the base is equal to this part here, AC. Now, we know that this angle here is 2 theta, which means that half of this angle is going to be theta, right? This is just going to be theta here, which means that our half length here is actually going to be 25 times sine theta, right? If we have a triangle, it has theta here, 25 here, and we're looking for our opposite, we know that sine theta is equal to our opposite over hypotenuse, which means that sine theta equals opposite over 25, which means that our opposite, this section here, is equal to 25 sine theta, right? So this section here is going to be 25 sine theta, which means that the total base of the triangle is going to be 2 times that, right? Because this is half to the midpoint. So our base is actually going to be 2 times 25 sine theta. Awesome. Now we need our height, right? So let's go back to our triangle. We know that our angle is theta and our side is 25. And this time we're looking for adjacent, right? So we know that cos theta is equal to adjacent over hypotenuse, which means that our hypotenuse is going to be 25. So 25 cos theta equals adjacent. And adjacent in this case is our height. So that means that our height is going to be 25 cos theta. Awesome. So where we go from here is we multiply our half by 2 times 25. So our half and our 2 can kind of just cancel because that's just half times 2 is just 1. So then 25 sine theta times 25 cos theta is 625 cos theta sine theta. Doesn't matter which order you do it in. Now this is a 3-mark question, guys. So this is our first mark, is figuring out the area of one of these triangles. So now let's figure out the area of the base. So the area of the base is a square, right? So we know that it's a square, and we already know the side length, which was 2 times 25 sine theta, which is going to be 50 sine theta, right? So the area of the base is equal to 2 times 25 sine theta, because it's that side, multiplied by the same length, because it's a square-based pyramid. So we're just going to do this squared, okay? So this is 50 sine theta, and that squared is going to be 2500 sine squared theta. Awesome. So that's the area of our base. That's our second mark. But we haven't found the total surface area yet, because we need to get 4 of these triangles and add them with the base, okay? So SA is equal to 4 times our area of a triangle, which is 625. I'm going to write sine theta cos theta plus the area of our base, which is 2500 sine squared theta. Let's just get rid of this bit over here. Awesome. And now, 4 times 625 is, you guessed it, 2500. Theta cos theta. And you can use a calculator for this one, guys, so please do that if you feel the need. Now, what we can then do is say that our surface area is equal to this, right? So 2500, so take 2500 out as a common factor, and then 2500 times sine theta cos theta plus sine squared theta. Third and final mark, guys, that is the surface area. Biggest thing here is the triangle and figuring out the theta value and all these side lengths. It can be quite difficult, but that's the reason that it's a show that question rather than just, you know, find the surface area. So if you have any questions, just hit me up in the comments below. So part AII tells us that model A is optimized for surface area. Find the value of theta such that the surface area of model A is at a maximum and state this maximum area giving both values correct to one decimal place. Awesome. So I'm just going to leave this surface area equation here because we're going to need this. So as soon as we start talking about maximum surface area or maximum volume or maximum length or anything maximum or minimum, immediately you need to think derivative and making that equal 0. Okay? So a maximum or minimum occurs at a turning point, okay, which means that our derivative is going to equal 0. So if we know that the surface area is equal to 2500 times sine theta cos theta plus sine squared theta, that means that our maximum surface area is going to occur when the derivative of this is equal to 0, or when the gradient of this is equal to 0. So what we're going to do is we're going to find the derivative of this, which in this case is going to be d sa over d theta, just like dy dx would normally be. Now, keeping in mind, guys, that we can use that calculator. So I would be doing that straight away. Don't try and do this in your head, or don't try and do it by hand. There's no point. So according to Kaz, and that's something that you should say as well, just according to Kaz, dsa d theta equals 5000 cos squared theta plus sine theta cos theta minus a half. Doesn't matter how they get it. All that matters is that you can get it in your Kaz. So because it's a maximum, the derivative is going to have to equal 0. So then we can say 0 equals 5000 cos squared theta plus sine theta cos theta minus a half. Awesome. First mark. Easy as that. So the fact that you recognize that you need to make the derivative equal 0 gets you a mark. Now from here, simply solve for theta in Kaz. Again, don't try and do this by hand because you don't need to. Solving Kaz, theta equals 67.5 degrees. Now, the question asks us for the values correct to one decimal place, so that's why I've done 67.5. Second mark. Again, easy as that. But we haven't actually found the maximum area, all right? So we need to find this maximum area. We know that surface area is equal to 2500 sine theta cos theta plus sine squared theta. So all we simply need to do is sub in this value of theta, and that'll give us our maximum area. So surface area is equal to 2500 times sine of 67.5 degrees times cos of 67.5 degrees plus sine squared 67.5 degrees. As always, guys, don't do this by hand. Always do it in your Kaz. Therefore, surface area is 3017.8 centimeters squared. Do not forget your units. You will lose marks if you don't include this. You could do a closing statement as well, saying max area or max surface area of 3017.8 centimeters squared occurs when theta equals 67.5 degrees. And that would get you full marks. Third mark right there. And that's it. So always, whenever you see the word maximum or minimum area or volume or length or whatever you're dealing with, immediately you should be thinking derive this and let it equal 0, just like we did down here. So let's move on to part BI. Now part BI tells us that we have a different kite, model B. And model B is optimized for volume. all right? And what that means is, well, not what that means is, that's the next part. So for now, we need to find the height of model B, bx, in terms of theta. So if you can just check, while you're watching this, if you can check out your little pyramid diagram. I'm not going to try and draw that because I'm gonna massively screw it up. But the important part is that we're looking for the height of the pyramid, which is our bx value, right? I'm sure you can see that if you're looking at your diagram. Which means that we're going to have to create a triangle to find that, all right? So what we're going to do is we've got this BM here, which is actually on a diagonal, right? Because if we're looking at the pyramid side on, we have our M value here, our B here, and our X in the middle, right? So if you can kind of imagine this as like a side-on view of the pyramid, we've got our M value here, B value here, and X value here, and this is what we're trying to find, right? This is the length that we're trying to find, BX. Now, we know that the distance from B to M is 25 cos theta, right? We found that out in the first part, because that's the height of the triangle, of this triangle here, BM, right? That's 25 cos theta. And we need mx, we need this distance here, right? Because we're looking for the height in terms of theta. So we don't need to know what theta is, we just need to come up with a value for bx based on this. Now mx, because it's halfway through the pyramid, is half the base of the pyramid, right? And we already found the base of the pyramid to be 2 times 25 sine theta. If this is half that, this is just simply going to be 25 sine theta. Awesome. So this means that bx is going to be equal to the length of this, right? Which is, like, let's say that this is Pythagoras' theorem. We know that a squared plus b squared equals c squared, where c squared is 25 cos theta. Sorry, c is 25 cos theta. So let's call bx a. So bx squared plus b, which is 25 sine theta squared, equals c squared, which is 25 cos theta squared. Now, from here, we are looking for bx on its own. So what we get is bx squared equals 20, so let's actually maybe, you know what, no, let's just leave it. So 25 cos theta squared minus 25 sine theta squared. And then we're gonna just, actually I'm just gonna take this out. So we're gonna take the square root of both sides, which gives us this. And what we can also do then is take out the 25 as a common factor. So we're going to get 25, so square root of 25 squared times cos theta minus sine theta, sorry, cos squared theta minus sine squared theta. And this 25 squared, we can just cancel the square root and the squared and get 25 root cos squared theta minus sine squared theta. Now this is a 2-mark question, guys. First mark comes when you recognize this, and you can kind of get here. And then obviously the second mark comes from the final answer. So guys, bx in terms of theta, bx being the height of the model B, is 25 root cos squared theta minus sine squared theta. As always, guys, if you have any questions, hit me up in the comments below. But let's move on to part BII. So part BII asks us for the volume of model B in terms of theta, right? So we know all the details of the pyramid now. We know that and the question actually gives us this as well, which is quite generous. The volume is equal to 1/3 times the area of base, so of the square base, times the height. Awesome. Now, from previous questions, we know that the area of the base is equal to 2 times 25 sine theta squared. Because it's a square, so we can get 2 times 25 sine theta here and multiply that by itself. And then the height, which we found in the previous question, is 25 root cos squared theta minus sine squared theta. Now let's clean this up a little bit, and we're going to get to V equals 62,500 times sine squared theta root cos squared theta minus sine squared theta over 3. And this is a 1-mark question, guys. It's not super difficult because we've already found this in previous questions and this as well. So we're kind of just merging everything together at the moment, and this will kind of come to a head in the next part. So in saying that, let's move on to part BIII. Part BIII rather, asks us to find the value of theta such that the volume of model B is at a maximum correct to the nearest degree. Alright, so I probably shouldn't have rubbed out that volume formula, but let's just rewrite it. So we know that volume is equal to 62,500 sine squared theta times the square root of cos squared theta minus sine squared theta. Awesome, over 3. Fantastic. So if we know, again, guys, whenever you see maximum, we want to remember that we have to derive and then make it equal 0. So if the volume is at a maximum, that means that the derivative of the volume is equal to 0. So dv d theta is equal to 0. So guys, let's find dv d theta. Again, this is a really, really complex equation, so we don't want to do this by hand. So again, according to Kaz, and guys, again, I'm sorry about the noise outside. It's like construction and all that sort of stuff. So dv d theta is equal to 125,000 sine theta cos theta times 3 cos squared theta minus 2 over 3 root 2 cos squared theta minus 1. I have no idea how they get this. Just do it in your CAS and you'll be fine. So that's your first mark, getting what dv d theta is. So because our volume is at a maximum, dv d theta equals 0. So we're going to solve this in CAS. Theta equals inverse sine of root 3 on 3, which gives us theta equals 35 degrees. To the nearest degree, remember. That's what the question asked us for. And this is our second and final mark. Guys, that is the whole of part of question MM219. If you have any questions about any of it, please post them in comments below. But otherwise, thank you for watching and have an awesome day.